Well, hey, everybody, this is Robert, and welcome to Outbreak News Interviews. Now, rat lungworm disease is on the rise in eastern Australia in dogs, and there have been recorded cases in humans, including two known lethal fatalities. Now, research by veterinary scientists at the University of Sydney have unveiled insights into what is behind the growth in the disease, also known as neural angiostrongyliasis. Now, their study is published in the Journal of Infectious Diseases, and I'll put that up real quick so you can take a look at it. And it highlights how climatic factors act as drivers for this potential public health issue. So joining me today to discuss this is Professor Jan Slapeta. Dr. Slapeta is a professor of veterinary and molecular parasitology at the University of Sydney and the senior author of this paper. Professor Slapeta, welcome to the program.
Thanks for having me, Robert. Very happy to be here.
You're so welcome. Yeah, and this is a topic I've done on the podcast a few times before, but I still want to go ahead and start out with an introduction to the audience who may not be aware of this parasite. Professor, can you give us a snapshot of what is rat lungworm or Angiostrongyliasis cantonensis?
Absolutely, yeah.
The transmission, the pathology, that kind of stuff.
Sure, I'll start with the name because the name tells the story, right? It's rat lungworm, and so it lives in rats and it's in their lungs. So it's a parasite of rats, and we would never care about it, and probably we don't, and we would not if there would be not the consequences in dogs and sometimes humans. The way it works, this parasite, is that it's circulating between rats, and all the feral rats, especially the black and brown rats that you have in US, as we have, as the world has. And the way they get it from each other is not directly. So one rat can't give it to another rat. It has to go through another so-called intermediate host, and that's a slug or snail. So we all know slugs and snails, they are in our backyards. Sometimes we step on them accidentally, and they are the intermediate host. So rat needs to give it to them, and they give it to them through feces. So yes, the lungworm lives in lungs, but the babies of the lungworm are coughed up. So the rat lungworm lays eggs and they hatch inside the lungs, and they coughed up, swallowed by the rat, and then they end up in poop. And the poop is then accidentally eaten by a snail or slug, and a new stage, kind of larval stage, a little more developed larval stage, is developed in the snail. And then it lives there ever after, almost, one would say. And that's a perfect way of a parasite to survive longer. If it would be out there in the outside, the environment might desiccate it, might kind of ruin it. So finding another host that it can kind of be moved around, it's actually very good ecologically to increase its fitness to get to a next host, because the rat might not be there, but the snail living for a little longer, the rat will sooner or later find it. And once it finds it, eats it, these stages that are there, the infective stages in the slug, will develop into the rat lungworm again. And now the story about the pathology, right? This is one of the most fascinating worms that we have out there. And the reason is they somehow decided to go through the brain. And that's very unique. No one wants to really go to the brain because, or they kind of, everyone wants to go there, but no one dares to go there because there's a very good protective layer. And we just don't have many parasites that go there. And this one really wants to and must go there. And out of all the worms, this is a very unique group. And so even in rats, they go there, but they very transiently there. They go there, develop a little longer there, and then move straight out and move into the lungs. Rats, because they kind of co-evolve with this parasite, don't really suffer any consequences unless, and we have seen some rats that if they've been infected with heavy doses, meaning thousands of larvae, then they become affected as well. But in general, you see no clinical signs in rats. And this is how the life cycle works. And if this would be happening, no one would care. It's just rats. But the unfortunate part is that parasites are exploring. They're exploring new niches. And when they enter new niche, few things can happen. And usually what happens is they enter and they say, no, we don't like it here. Or the host says, no, I don't like you. And they kick it out. With this parasite, because it's so fast and so quickly wants to find the brain, in some animals, which is, as you mentioned, the dogs, it just goes to the brain. And there it stops. Because it's so rapid, it gets there without even the host recognizes that it's going there. But only when it's in the brain, it starts to cause the havoc, because that's where the dog's immune system kills it. And it essentially becomes a foreign body inside the dog's brains. And that's obviously not good, and causes inflammation, causes all the immune triggers, and leads to headaches, serious headaches, and potentially even worse consequences. So I know it wasn't a snapshot, but that's how it works.
and then, of course, humans can get infected also. And again, that's the parasite also going to the brain.
Yeah. And I'll tell you, well, it's not just dogs, it's not just humans, it's also the wildlife. This parasite, as the name says, it's Angiostrongyliasis cantonensis, which means it was first described from Canton region in Southeast Asia. And that's where it was recognized in rats. And it was like many thousands other parasites that are described and kind of not forgotten, but just named and become part of a catalog of life. And then it just became known for this disease because of this venturing into alternative and a non-normal body. So we call these wildlife species, humans or dogs, kind of dead-end hosts or accidental hosts. Yeah. And in Australia, particularly, we have problem with this, not just in dogs, we have in humans as well, but also in the wildlife, because a lot of these pristine areas in Australia were not really in contact with the rest of the world for many, many thousands of years. The Europeans came here a couple hundred years ago, right? And brought also things with them, and including this life cycle. And all of a sudden, all these kangaroos, possums, and our bird life, they are affected quite heavily, because they do sometimes munch on slugs and snails. And if they have this parasite, unfortunately, they suffer from it. So it is quite known on this east coast of Australia that possums and something that's called thorny frogmouth, which looks like an owl, but it's not an owl, they're kind of falling out of the sky and with serial neurological disease. And that's simply just because of this parasite that got into their brains, died there, and the inflammation in the brain is so severe that they can't coordinate any more flight or a movement, and they become victims of this parasite.
Now, I think this is basically considered an emerging pathogen in your country. And you mentioned Southeast Asia. What are the other geographic distributions globally that you see this more commonly?
Yeah, look, it's hard, the word emerging, right? In Australia, it has been emerging from 1950s. So can it still be called emerging? I don't think so, really. But it's let me just tell you the evolution of kind of the history of it. It's believed that it came after Second World War with the movement of the troops around the Pacific, and probably including some of the wars that were there in the 50s, and a lot of movement of troops moved across the Pacific into Australia as well, probably in the 50s or late 40s. But it was just a curiosity. There was no human cases in Australia. The first human cases became known only in the 1970s or very early 70s. And it was up north, up the tropical kind of Queensland. And there was no more. Then just stay there. But in the 90s, very much the first human cases were recognized in Sydney. And then in 2000s, early 2000s, it was in dogs as well. So there is some sort of a genesis. And as far as emerging, rats are everywhere, right? Like any of our U.S. cities as well, and across Florida, I'm sure you've got plenty of them around. And so we have them around as well. So how far it can go? Can it go further? It's at this moment located on the sort of east coast of Australia. Does it go any further? It can. So in those places where we don't know, it will be emerging or has the potential to be emerging because the conditions are there. What are the conditions, right? Having a rat, we all have that. Unfortunately, they're everywhere. We can't get rid of them easily. Do we have the right snails and slugs? Unfortunately, we brought that over here to Australia as well. And usually the common ones, the leopard slugs and similar kind of invasive slugs and snails, they're here as well. And they are across the country already. So the conditions are here, or at least the hosts are. And the parasite, it's conditions for parasites to move. Now, that goes back to the environment, right? What do slugs and snails want? I mean, there's no rocket science in it. They want humidity, they want rain, and they want shelter, right? And that's kind of what our kind of paper that you mentioned kind of explored. How much is this connected to the emergence of these cases? Essentially, we looked at dogs because dogs are a very good proxy to a lot of things. We do care about them. There is a very good veterinary care, and they do venture a lot in the backyard. So we walk them in the mornings, afternoons, spend time with them outside. So they're very good proxy to it. And we're fortunate to have a diagnostic test, and we're testing at the university the dog's CSF, which is the fluid that kind of is in our brains and spinal cord, as a sort of material where you can detect bits and pieces of the worm. And gathering data over the past 5 or 6 years enabled us to develop a little model to explain or try to explain what correlates with occurrence of these cases in dogs, because we have around 20 to 30 cases like this, which is not much, but I think it's significant compared to what happens as far as the consequences and sequelae of this. So with these numbers of cases, we can develop, or we were able to develop a little model to explain it.
Yeah, well, let's go ahead and talk a little bit about the study. How did you go about it? Because you looked at you and your colleagues looked at a 5-year period, and so if you could talk about the methods and then give us your findings and why is this a concern in Australia, Eastern Australia?
Well, look, it all starts with kind of people working together, and I think projects need the sort of One Health kind of. There's this word, One Health, where vets and medicals work together, and we often see things sometimes a little earlier, or sometimes we see it from the vet point of view. We see it from a different kind of lens. And we got access to different sets of material. And this is a classic example where One Health nicely works. We have a tool, we have this molecular test, and we have dogs and veterinarians that are quite well aware of it and are able to submit samples to us. So this is how it started, that there's a bunch of vets kind of very keen to know what's going on. They can diagnose it clinically, but they need that evidence, that sort of a test that will really confirm to them that, yes, they're dealing with rat lungworm. And so we provide that support. And at the same time, we're getting all the kind of information with these samples, catalog it, work longitudinally over time. And all of a sudden, it starts to clear the picture. And the picture is very much that this is a reasonable seasonal disease, or it occurs seasonally. And now you have to excuse me, we kind of on the other side of the planet, right? You got summer, we got winter. So just bear in mind that that's how it works. This is the prime season for rat lungworm in Australia. We're in southern hemisphere. It's always kind of the autumn towards the winter. So for us, it's May, June, probably July. This is where it's kind of the peak of the season, and it really reoccurs each year. Kind of, this is the seasonality of it. So that's kind of indicated that it's not just happening all the time, that there is some sort of a seasonal trigger, and that's kind of helping us immediately. And because, as we discussed, we know about the slugs and snails liking moisture and rains, and we said, well, Australia is an awkward country as far as the rains and floods and all this. And there are seasonal rains, heavy seasonal rains. And in, for example, 2022, we had massive rains. I mean, massive, what do we mean massive? We had more than 2 meters of rain here. So that's a very tropical country, very rainy country. And they come seasonally as well. And it's not, there can be big rains once in every while. And so we said, well, why don't we plug all this information about the climate, temperature, rainfall into this model and kind of overlay it with the occurrence of this disease and ask a few questions whether this is associated and whether that's kind of there is some link to it. And essentially that was the outcome, that it is the rainfall and the temperature really is clearly associated with, and there's significant association with the occurrence. And it's not direct, kind of immediate, that there is a delay, that it's not that it rains now and now there will be the cases. It is often that there is a rain and then only months later there will be these cases, or it can wait for another 11 months. And again, when you look at the biology, what we discussed, it's not instant, right? The rat needs to kind of provide the environment for the larvae and adults to develop into adulthood. And it takes a few weeks before it starts to produce the stages in the feces. And then in the snail, the same thing. They need to be at the right temperature and for right lengths of time to develop into that infective larva inside them. So if you look at this, then you start to put the numbers together, add the lengths of time in a rat, lengths of time in a snail, and then kind of surviving the harsh times through the time when it's not ideal. That's exactly it increases the fitness of the parasite to survive longer. If it would be just the larva in the environment, it would die out. But it's got the snail to stay a little longer. And so all of a sudden, it just makes perfect sense. So why is it significant? We do not have a predictive model. It's all kind of, this is what the data are. This is how it kind of makes sense. Predictive models are much, much more complicated. But we are on a first step towards kind of working towards this stepping stone, towards that maybe one day a predictive model, but I can't promise whether that will work out. But this is the significance of this is really that we can start see that pattern, and not only we see the pattern, but with the increasing rains and increasing amplitudes of the rains that we have seen over the past 10-15 years, at least in Australia, and the record-breaking rainfalls that we have, this is a perfect kind of ground for this parasite to kind of establish, spread, and be really, really prevalent. And this is potentially kind of significant from one point of view, that if I go out in the city and pick up 10, 20 rats and look how many of them have this parasite in their lungs, probably 2 to 10 will have it. So there is about half, 1/5 to a half of rats in Sydney that run around the bins and around the shops, and and backyards are positive for it. So provide the rain. Rain will bring in the slugs, and immediately we have conditions that are ripe for dogs to get this parasite and unfortunately suffer from the neurological disease.
Right. And from a human public health aspect, I would imagine it's education of the public. Wash your vegetables, your lettuce, and all that. You might have snails in it. Don't take a dare on eating a snail or a slug. I mean, we've seen that, right?
Yes. Look, it is. Look, what are the? This is kind of a epidemiologist, right? People that look at data and tell you what's the risk. They define risk, and this is essentially when you look what are the risk factors for these rat lungworms. And I start with the dogs, and then I'll move on to the humans, right? So we know the risk factors is the seasonality. That we know that. We already talked about. But what about the dogs themselves? It's always young dogs. So if I would say, if I see a sample coming from a 6 months old Labrador male, I am kind of very, very. This is like hitting all the spots. That's the right breed because they like to eat all sorts of things. Young ones, male, they like to venture and kind of taste the territory. Those are the triggers. So essentially, that's the young dogs, males, very often, and the seasonality tells me that that's the right time and right kind of animal that will be in the risk and will have the indicators that it's suffering from this if it's got the right clinical signs. Now, translate this onto human, right? It's very much young kids, toddlers, very young toddlers that kind of crawl on their fours and taste the dirt and taste anything. They will be putting everything into their mouths. And anyone who's listening and they got their kids, they know that what they do. Their teeth are coming out. They want to put stuff in there. That's what happens. So really being vigilant about this, that's the important part, that they're not putting slugs in their mouths. That's the key. And really that's what we have. That's what, when we see it in Australia, we see this very, if we see rat lungworm in humans, it is very much this category, toddlers, young children that suffer from it. It is probably 1 or 2 cases a year like this that are on the east coast of Australia, no more. And for you in US, I think I didn't answer one of your questions in the past. What's the geographical distribution? Now I'm realizing. So I probably should pick up on this now. It is in Florida. It is in the southern states.
Yep.
And you do have, what is interesting, and what's really puzzling me, and I'm still can't put the finger on the pulse why. You have cases in the wildlife, right? You have rats full of it. You have even human cases. Again, the same conditions, like young children, very young children, but no dogs so far. There is no record of a dog suffering from angiostrongyliasis so far in Florida. Why is that? I do not really know, but I would love to know, because maybe there is something different between you guys, and are we doing something strange here? We should be doing what you're doing, but I don't know what that is. I'd love to know. And where else is it? It is South America. It's already in Brazil, across there. That's quite prevalent there. Human cases well known as well. The Caribbean as well. In as far as states, part of the southern states, it's in Hawaii, where it's a serious problem because of one particular intermediate host, which is not a slug and not a snail. It's called semi-slug. They hide very well on lettuce, on veggies, so very hard to wash. And we have to go back to Europe as well. In Europe, it's It's coming. It's coming from the Mediterranean. So it's in Balearic Islands, in Spain already. And how far is it going to go further north in Europe? I don't have a crystal ball, but I don't think that's staying just in the areas where it is now. So that's the distribution answer that came a little late.
Well, it seems like there's one common factor, that it's more or less warm, wet weather. All these places that you mentioned, right?
A lot of rain.
Yeah.
Once you got a lot of rain, that's what's coming.
Yeah. Good stuff. Professor, do you have any plans to follow up on this research, to take it to the next level, or?
Look, there's few plans, and there's always plans, right? One is really, at this moment, the way we diagnose it is really from CSF, which is cerebrospinal fluid, and it's very invasive process to collect it out of dogs. And so having a test that would not require this type of a sample is probably a priority. It would be great to have some sort of blood test. So I'd love to see that. I would love to explore that. And then really the next part, this is kind of very applied, the fundamental part is that the parasite exists in multiple different variants, if you would call. Some of them made it to different places, some of them did not. In Australia, we got essentially just two variants, that are genetic variants, and they seem to be at least behaving differently. Behaving, I mean that they may be, and I don't have a proof, that they got different virulence, different kind of attack power onto the animal. So I'm very curious to know whether that's probably one of those reasons why we see it in some parts first, and some other parts we don't see the pathology yet. So that's kind of our avenue to go to explore whether there are kind of sort of conditions within that parasite, within that we can label a parasite. This is the virulent one. This is the one that's the baddie, and be able to kind of learn whether there are any ways we can kind of track that and find a ways how to kind of eliminate that one compared to the less virulent. And look, it's a very hard parasite to track. It does not really the antibodies, which is the human way of producing some sort of a signature that I've seen this, I'm ready for it. It's not good. They don't last at all long. So if you would ask me the question, so how much of a population of dog has been exposed to it? I don't know. I have no idea. What's the population of humans that have been exposed to this parasite? I don't know. I don't have a tool. We don't have a tool. Yet maybe the clinical signs, it's on a spectrum, right? If dog swallows a large number of the larvae, it leads to a disease. But if it's smaller number, maybe I just got a little headache that I'll just move on from. And if I swallow one or two larvae, it's nothing. It's just asymptomatic. Nothing will happen. So, but how much of the population of dogs and humans is actually exposed to this parasite? I'd love to have a tool to know that. That is a little challenging with what we know. That's my kind of bucket list of knowing that.
Well, it sounds great. And when you start digging into this bucket list, I love to hear more about it. For sure. It kind of reminds me of here in the States, we have this issue with raccoons and Balis ascaris, right?
Absolutely.
And it kind of reminds me of the similar scenario, sans the snails, right? But little kids and
Yeah, it is kind of, look, raccoons in your attic up in the roof, right? And possibly, spreading the eggs around. Absolutely, yeah.
All right, well, let me put up the study one more time. The study is titled Rainfall and Temperature-Driven Emergence of Neural Angiostrongyliasis in Eastern Australia, 2020 to 2024. It's published in the Journal of Infectious Diseases, and I'll link to it in the show notes if there's anybody in the audience wants to check it out. And I want to thank you again, Professor Jan Slapeta, for sharing your time and your expertise, sir. I appreciate it.
Thank you very much. Thank you for having me.
You bet.
All right.
All right.